All right, everybody, we're back. Let me try and retweet everything out here. So this is the view from Thad's telescope. If you're seeing the eclipse coming through, Thad is right behind me.
Hello.
Hi, Thad.
Hey, Scott.
I'm going to switch webcams so that maybe people can see us as well, as it's kind of bright out here, as you can see. Hey! So it's really windy. We're on another connection here, but and hopefully we'll hang out. And it's Katie. Katie's back.
I'm back. Hi.
Back. Thank you. So I'm now tethering my cell phone instead. We'll see how this works.
Okay.
And I've given up on using the binoculars right now, so we're just going to be looking in H alpha, which looks amazing anyway. So let's stick with this.
It does.
And I'm going to tweet this out. Here is the YouTube link. Put that here in the chat. And we can also try to share that. So I appreciate everyone's patience as we're back online. Tweeting.
Yeah, that's on the computer image. That's out the big telescope.
Okay, I tweeted out the link too.
Awesome, thank you.
Oh, by the way, my office mate is now in the office. Over there, so, I will try not to disturb him too much as we're doing this.
It's science. We can disturb him with science. Alright, try to get this up on Facebook.
So, wow, so the eclipse like totally swallowed up that filament, didn't it?
Yeah. It
That's
just
pretty awesome.
for now. Yeah. It'll come back.
Yeah, it'll come back. Yeah.
Like the moon is not actually eating the filament. So that would be kind of cool.
No, although I've heard that in ancient times they didn't know what was happening with solar eclipses, and they thought the moon was eating the sun, or something was eating the sun.
Right.
And so there would be these. They would try and like scare away the monster that was eating the sun to end the eclipse. It always worked eventually.
I mean, yeah, they did a great job. I mean, they did have a 100% success rate, which is great when you think about it scientifically. You know, they do something, has a good result, but there might be some other variables involved, like the fact that it wasn't something eating a star. Maybe.
Yeah.
And I'm now into sarcasm mode.
That's what it looks like right now?
Yeah, I'm on air right now.
Okay.
So we're looking through that telescope over there, and like I said, everyone out there that's watching us, we are live at Cerritos College in Norwalk, California, looking at the partial solar eclipse. What you're looking at right now is you're looking at this through a Coronado PST, which is a hydrogen alpha telescope. So we're looking at it from a very narrow band of light, as opposed to what we were looking at earlier in the other feed, which is just a broadband. It's a white light filter, so it blocks out around 99.9% of the light, and so it's just dimming it all down. Now we're looking at it through a very, very, very specific narrow band of light, and that's why we're able to see a lot of the detail and the structure that's going on here with the sun. And it's really warm out here. Hi, it's bright, it's sunny. I should have worn sunscreen, but I didn't.
Yeah, I mean, you knew you were going to be specifically observing the sun.
Right. Well, I mean, so I do have shelter, kind of,
Okay.
but the way that it's set up and the way that I need it to with my cords, I'm not able to actually be underneath the shelter.
Right.
So we did think ahead, but you know, cord length ended up being an issue. So I will have a great sunburn on the back of my arms and neck when we're done. But it's worth it. It's worth it.
Yeah.
One thing our viewers are rolling back in. What's that?
On the bright side, you'll have maybe like 10% less of a sunburn than you would have if it weren't a solar eclipse happening.
Yeah, but isn't it like 40% is going to be occluded? So I'll have
Well,
like
yeah,
a
but averaging over the whole time that you're out there, right?
true. Very, very true. But it's hot. And let me see if I can turn the Q&A app back on. Because, hey, I was loving answering all your questions, and I don't think that I can right now. So I apologize. So if you do want to get a hold of us, I will, actually I can put up my lower third though, and now Katie can too. So Katie is on Twitter at AstroKatie.
Yes, and that should be visible now. Yes, I'm Astronomy on Twitter. I've been putting some pictures of the eclipse that happened in 2012 here in Melbourne, and tweeting some other pictures of how you can use pinhole projection to see the eclipse even if you don't have special glasses. You should never, we should reiterate as much as possible, you should never look at the sun directly with your naked eye. That's a bad idea.
Yes.
If you have solar eclipse glasses, if you have sunglasses, like not just regular sunglasses, but special eclipse glasses, then you can look at the eclipse through those. Or even if you don't have anything like that, you can use pinhole projection where you take a piece of paper or something like that, and you just poke a hole in it and let the sun shine through that and look at the projection onto something else. And that's a great way to see the shape of the eclipse. You can also see the shape of the eclipse if you just kind of make sort of crosshatches with your fingers and let that project onto something. Or if you look at the way that the sunlight comes through trees, through the little tiny holes between leaves and trees. Lots of ways to see the shape of the sun, even if you don't have any equipment at all. But we do have equipment. We have a beautiful, beautiful H-alpha image of the sun right now through a telescope, which is awesome. Can you?
I've got my very, very, very sexy glasses. I can't see you right now, but I can see the sun.
Yeah.
Am I looking classy, Internet? Yeah?
Yeah. Yeah.
It's cool. Very good. So I'm able to see the moon going across the sun. And now I'm going to look at you guys again, so I can actually see what's going on, even though I'm like terribly backlit because the sun's behind me. And our telescopes, so there is what we're viewing, if you see it over here, on I guess the left-hand side of the screen for you guys, that is what is projecting our view of the H-alpha. And then these are right here, my binoculars and webcam setup, which I had disconnected right now. Because it's being a pain.
Can we show that H-alpha image again?
Yep, it's up right now.
Okay, yeah. So that's just a gorgeous picture. You can see the prominences at the edge of the disk of the sun, and you can see that massive active region sunspot. So very impressive. I have to do a shout out. I just found out that my mom is watching from Newbury Park in California. So, hi, Mom. she's a lot closer to where you guys are right now,
yes.
And she has probably seen at least the pinhole projection of the eclipse. Hopefully, when I was a little kid, my mom used to take me to see all the eclipses and stuff at Griffith Observatory, which, by the way, is doing a live stream of the eclipse if you want to see another view of the eclipse going on right now.
There are many. Yeah, it is awesome. There's so many different live streams that I know of. I know we're doing ours. There's one up at Griffith. I believe SLU is doing theirs as well. I think there's one more. I'm not exactly sure, but I know there's at least 3 going on for this event. And like for the first time, the last time I did a solar eclipse, I was my view was the only one that didn't get clouded out, so it was a pretty big deal. We got a lot of views on it because everybody ended up being clouded out. So I'm really happy that other people are able to participate in this as well. And over here, manning the camera and the telescope is I can move it over there. There's Thad. Hi, Thad. Just like Sean Zabo. He is the professor here for astronomy at Cerritos College, and that's his face on the camera. So we're no longer looking at the eclipse. No, we like you. You're pretty. Yeah, there you go. There you go. Yes, that's okay.
Terribly, yes.
Yes, that is a bit more impressive. The filaments on the sun are much more impressive than your beard. Barely. That is an impressive beard.
Face filaments.
Face filaments, exactly. So, yeah, we're getting silly, and I like being silly. So, hey, it's cool.
So, aside from the fact that the moon is blocking out part of the sun right now, the other big star of the eclipse is that big active region on the sun, those sunspots.
Yes.
Scott, what do you know about sunspots? I was telling the watchers a little while ago about how sunspots form, which is through sort of magnetic field processes on the sun.
Mm-hmm.
But they can also disrupt communication if you get a big solar flare, if you get a coronal mass ejection. Do you know what scale this solar flare is on? Is this something that's going to cause us problems?
Actually, I was just talking with Dad a bit ago. Do you know what class that flare is?
There was a flare?
If with how big this is, if it's a flare, I know that we were talking about it could potentially cause some issues.
When I looked this morning, the count was in the past, I think it was 60 hours, it's fired off 27 C-class flares, 8 or 9 M-class flares, and 2 X-class flares.
So
that's
what is
just,
that?
That's just in the past 2 days, roughly, that it's had that much
So-
activity.
So what does that mean?
That the magnetic fields there are severely distorted, and as they rearrange, they unleash pretty huge amounts of energy. Now, the X-class flares we've seen, there was an X1.1 and an X1.6, so that's kind of just the bottom end of X-class. It's still a lot of energy and causes radio blackouts when it happens.
Right.
But we have seen flares on the sun in the past solar cycle as big as, I know, more than X8, possibly X10. And so you're talking 10 times the amount of energy released. If this one fires off one like that, pointed straight at the Earth, probably be a CME that comes with it, and, well, we'll just have to see what kind of effects that might have.
So,
But they wouldn't be good.
this active region has put out it put out some flares as it was coming around from the edge of the sun. Right, the sun is rotating.
Right.
And it has a period of something like 24 days.
Something
Is that
like
right?
that.
Yeah, if you're turning in the time, right, Astronomy.
And so the sun is rotating, and that huge solar flare, that big active region, was on the edge of the sun, and that let out some really big solar flares when it was on the edge. And now it's sort of rotated around, so it's closer to facing us directly. So is it correct that we're kind of just hoping it doesn't get too excited while it's looking at us? Is this
Well, I
what's
mean,
going on with that?
I think that's the big thing too. Yeah, is we don't want it to be pointed at us, especially if it is having the larger X class. Because I mean, even though we've done a lot, we as humanity and science has done a lot to shield our satellites and things like that from the solar radiation. When you're getting something that bombards it with that much, with that much energy and particles, charged particles like that, who knows what's going to happen? And it really compresses our own magnetic field a lot, to where we see a lot of aurora coming down further south for us in the northern hemisphere and further north for you in the southern hemisphere, and have a lot of interactions going on. So I think I'm hoping, okay, so the scientist in me hopes that it comes out. Because I'm like, this is awesome. This is something that we can study, and it's really exciting. Like, yes, let's find out what happens. Hopefully without catastrophe. I do not want to have catastrophic results, but yeah, I think for the general good, as far as making sure lots of damage is done, we're hoping that it doesn't have anything aimed towards us. as it's flying through space, if there is a CME that comes along with it. And the CME is a coronal mass ejection. So as we can see here, we're seeing those filaments, those filamental loops, and they're strong magnetic fields where the plasma is caught with inside of it and loops back into the sun. But sometimes it gets so strong that it actually breaks. That magnetic loop itself breaks and it ejects. It has this coronal mass ejection and it releases all these charged particles across space. And sometimes we just happen to be in the path of that when it happens,
Yeah.
which is no bueno sometimes.
Now if I recall correctly, if a coronal mass ejection happens, the astronauts at the International Space Station sometimes have to sort of stay in a sort of more shielded part of the space station, and they can't go out and do spacewalks during those events. But for the most part, they're not in danger from these things happening. They just have to be a little bit more careful.
Right, because there's a lot of radiation out there in space that they have to take into account, anyways, and just the more that we've learned about the sun and CMEs in general, I know that there's been a lot of research and development to making sure that for most cases we keep our astronauts as safe as possible. And yeah, I think going out on spacewalks while there's a CME heading for us is not really the best thing to do. So yeah, I think just basic safety protocols would be stay in the more shielded areas, and don't pull a George Clooney from Gravity and just decide to go out for a spin. Which awful movie. It's a beautiful.
It was a great movie.
I love the
movie. There were a few little sort of scientific issues, but it was a great movie. It was just amazing to watch.
Cinematically, it was beautiful. I had some major issues with it, mainly because I work so much with the Hubble Space Telescope, and I know the orbits. And you're like, yeah,
Take a look at this last one.
Like I know that the orbit of the ISS and the Hubble are nowhere near each other, altitude-wise, and yeah, okay. We won't spoil this for those that have not seen it. I do recommend watching the movie though. So go watch it. I have my grumpy Scott.
Okay. I'm looking at the H-alpha image of the sun that we've got there, and you can see that that filament coming back as the moon is no longer blocking that part of the sun quite so much.
Right.
I'm just gonna quickly screen share a picture of the sun in. Let me just check what wavelength this is. In extreme ultraviolet, where you can see that
very high energy.
Filament. Yeah, and you can see that filament more in this picture. So this is earlier. This was like a day ago when the moon was not blocking the sun. And you can see this massive filament in this sort of upper left corner of the disk of the sun, and that's something that we can also see in our H-alpha picture of the sun right now. That is just coming back into view after being blocked by the moon a little bit, and you can also see in this picture from the ultraviolet that huge active region that we're kind of hoping doesn't get too excited.
I still want it to turn into a CME. Maybe I'm a bad person, but CMEs fascinate me. These coronal mass ejections. I think it's awesome about how this is the closest star we have to observe. And so the more we learn about the way that our star works, the more we're able to understand how other stars work. So to me, in the idea of astronomy in general and learning about helioseismology and the way that stars form and act and things like that, we can see more amazing things that come from our star. Being able to study it with with SDO, the Solar Dynamics Observatory in Soho and things like that, we get really, really good observations, and we can also help understand better what's going on with other stars that we're able to observe, especially if they're similar.
Yeah. Yeah, I mean, yeah, we have a bunch of different things staring at the sun right now. Partially to better understand it, because we've got this star right here that we can observe and look in all different wavelengths to see the different processes. But we also watch it for sort of our own protection, because if there's a satellite, if we have a satellite looking at the sun and it sees a big solar flare, then it's getting the sort of photons early, and it's getting some of those charged particles a little bit before we do, and so we get a little bit of time, a little bit of advance warning to know that something's coming toward us, then that we should get ready.
Right, and mainly because it gets the charged particles are going to be moving a little bit slower than it is for the photons. So as soon as it's getting that information, the charged particles, it can beam it back to us at the speed of light. We have a little bit of time, not a ton of time, because it's still going extremely fast. And that's why we have these sorts of projects out there, to allow us to better protect our planet and learn more about the solar system and how other stars form. Well, I'm going to try and pull up some of the questions from the old event that we had going, because there were still a lot of questions that were going on, and I just didn't get to answer all of them. So I'm going to try
Do we have the Q&A? Do you have the Q&A for this one set up? No? Okay.
Well, I was rushing. I did not get it turned on, unfortunately. But I will go through, because there are still a bunch of questions that are up. Let me see here. Let's see. I want to go to unanswered questions. There we go. Yes, Nicole. Man, so many questions to go through. Let's see here. This one from Daniel Loves. Like, I just went to Iceland and photographed Aurora for the first time. Does this mean I should go back right now? Can we order a sunspot for the spring? Thanks. That's a great question. So I mean, we have Aurora pretty regularly, but when we're getting more of those charged particles, that's when when we're getting that solar activity interacting with our magnetosphere, that's when we're starting to see those auroras happen more vividly and at lower or higher latitudes, depending on what side of the planet you're on. Because the Aurora Borealis that we see here, the northern lights, are exact matches to what we see in the southern hemisphere, the pole. They're just flipped around, because they correspond like magnets, believe it or not. The magnetosphere works like that. It's crazy. But, so yeah, I think, the further north you go in the northern hemisphere, the further south you go, the more you're going to be able to see things like that. And if we're getting large flares and CMEs heading our way, that's definitely prime time to go out and observe that. Have you ever seen the auroras?
I haven't, no. I've never. I tried once. I went to Alaska and tried to see the aurora, but it was cloudy.
Aww.
So I didn't get to see it. I was bummed.
I've seen them once. I've seen the aurora once, and this was back in 2003. When was the last max?
I don't remember.
Yeah, it's 11 years. So 2003, and this is back when I was in Detroit. So not that far north for the United States, but really not that far north. But I was actually able to see the auroras in Detroit, even with all the light pollution and stuff like that. It was really awesome.
Amazing. Yeah, and I would love to see that.
I didn't really know what it was at the time, because I'm like, why is there this greenish pink stuff in the skies? And that's what ended up going, is that the auroras were happening, and it just happened to be it's another solar max cycle, which we are in right now. We're finishing up right now with the sun, where its magnetic poles flip.
So
and not necessarily flip, but turn through the sun.
Right. Yeah. So I was chatting with somebody the other day who works at a neutrino detector at the South Pole in Antarctica, and one of the things that you have to do if you work at a neutrino detector at the South Pole is that you sometimes have to go and spend the whole winter down there to kind of keep it going. And you have to spend the whole time because you can't get in or out of Antarctica during the winter. It's too cold and it's too difficult. And so you don't see the sun for like 6 months, but you do see Aurora, and that seems like that would be kind of enough consolation. You know, you don't see the sun, but you see those southern lights. That would be pretty amazing.
I think, even though it would be bitter, bitter, bitter cold all the time that winter season, just the chance to go out and having your only main light source being charged particles interacting with the magnetic field of our planet, that being your light source, just thinking about it that way, that would be fantastic. I think that would be wonderful.
It would be pretty cool. Yeah. I mean, and you must be able to see some amazing stars as well, like Milky Way and everything. Because in the south, you're facing the center of the Milky Way, so you get to see that, and you get to see, there's no light pollution.
Which we're really jealous of here in the northern hemisphere. We don't really get to see too much, especially like here in LA. Unless there's a blackout, you don't really get to see it because there's so much light.
Yeah. Although it's not, even in LA, it's not that hard to get a little bit away from the city lights and see some good dark skies. When I was living in LA, when I was growing up there, I used to go out to the mountains sometimes to see things like meteor showers and stuff like that. And it only takes a couple hours drive to get somewhere really dark.
Right. I will go out to like Joshua Tree or something like that. If I'm out here, I'll go south. A little bit outside of San Diego, there's some nice dark sky. Although I had to say I was really, really, really spoiled when last June I went to Hawaii and went up to Mauna Kea, and oh man.
Wow. Yeah.
I thought I've seen dark skies at some different dark skies, refuges and stuff like that. But the skies and the seeing up at Mauna Kea was phenomenal.
Well, there's a reason. There's a reason they put some of the best telescopes in the world up there.
Right. For me to go visit. Isn't that right? Isn't that why they put them up there?
Yeah, more or less.
Yeah. You're absolutely right. The seeing up there is great. It's at such a high altitude, like that you literally there's warnings up there that if you have to stop at a rest center for a while, for an hour, to get acclimated to the altitude before you can actually go up to the summit, because so many people get altitude sickness going up that high. And you're above the clouds at a lot of the point, and it's beautiful. It's absolutely beautiful. I remember I just sat up there for a while, and you could just watch meteors the entire time. It wasn't meteor shower season, but you're able to see them because there's no light pollution.
Yeah, because there's little bits of dust hitting our atmosphere and burning up in the atmosphere all the time, and so we see meteors constantly if we have a dark enough sky.
Right.
So you don't need a special meteor shower. It's just the fact that we live in space, and there's stuff in space. Every once in a while, some of it will hit us, and they'll be pretty good.
Yeah, I forget the exact number, but I know that there are tons of space debris, space dust, and space rock that goes into our atmosphere every single day. It is a gargantuan amount when you think about it, and how much stuff is falling to Earth every single day, yet we just don't notice it.
Yeah, I mean, our atmosphere does a pretty good job of protecting us from it, and a lot of it's so small that it burns up immediately and doesn't even make a big splash. But every once in a while, you can see those nice meteor trails.
Right.
So, looking at the H-alpha picture now of the sun, the eclipse, you can really see that filament no longer being blocked by the moon, and it's pretty impressive. That's pretty huge. I mean, that active region that you can see there, that's about the size of Jupiter. So that
Right.
eclipse, so that filament is longer than the size of Jupiter, than the radius. That's pretty impressive.
Yeah, I mean, so yeah, the for those we're talking about that darker region on the right side of the screen, which is what active region 2192, I believe, is what it's officially called. And then yeah, if you can see here, there's that slight long band. Yeah, that's right where Dad's mouse is pointing right now, as it's moving
Yep.
away from. That's actually a filament on the sun that is far longer than that object that's larger than Jupiter. I mean, at least what? Let me say like 4 times. I would say 3 or 4 times longer.
It's hard to tell because, yeah, I don't know exactly how you define the region, the active region, in terms of its size, but it's pretty big. It's a pretty big
It
object.
is pretty big. It is a monster. And I just
Yeah,
realized
I mean-
that when I hooked up to a telescope, I can actually sit down in the shade because I have a full 30 minutes to think that. So I'm going to do that and be in the shade and not get sunburnt anymore and talk to you guys. Yay! All right, let's try this some more. Hi, everybody.
You've got some pretty massive glare going on from the sun there.
Sun? What? We're here for the sun. I can't really do much about that right now.
Can you show us just while you're sitting there? Can you show us the technique for a pinhole projection image of the sun? Since you've got the sun right there, and you can demonstrate for those of us of our audience watching who do not have a nice don't have eclipse glasses and don't have a nice telescope and filter. How can they look at the?
I'm curious right now if I can do this.
Okay.
Can't see my screen. Hold on.
All right.
I'm holding Eclipse glasses up to
Okay.
the camera
I
and
can kind of
saying
see something.
I can't see it all because of the glare on my screen.
Okay. Yeah, it's not the best picture there.
But yeah, now you're blocking the sun. Yeah. All right. So I was trying to do that so we could see how that works, but I don't think it's gonna. Oh, there it is. There we go. So there's the sun through Eclipse glasses, and my computer is trying to focus, and it's not doing a good job.
It's not really working out. But can you show us with the pinhole projection?
Yeah. Let me see if I can get a piece of paper out here. Hey, Thad, do you have a? Nope. And I don't have bucket paper. I don't have paper.
I think you can do something just by doing this with your finger and
Yeah.
kind of projecting that onto a piece of paper or anything.
Let me see if I can go here. So I can do this correctly and have you guys see
Okay.
without my fat head being in the way. Hold on. Let me move my cords out of the way. So, moving. There we go.
Okay.
It's gonna be really hard to see. I'm trying really hard.
Okay, so it's a bit hard to see, but yeah, maybe see it. But that's the way that even if you have nothing at all, you can get a nice projection of the shape of the eclipse sun.
Right. And it helps if you have an actual pinhole and not my hands holding up while doing all those things. But if you can keep it perfectly in line with what you're doing, you do get that projection like what you were seeing, what you showed us before. One that you did. That was one that you did 2 years ago, right?
Yeah. I'll share that again. Hold on, let me find it. Okay, yeah, I'll screen share that. So we had an eclipse here in Melbourne, visible from Melbourne in 2012, and I took a little picture of a pinhole projection of that eclipse from my living room. Actually, I was able to the sun was coming in through the windows from the east, and I was able to see it just sitting in my living room. And so I did some pinhole projections, and I drew a little picture and projected the image of the sun into that little picture, and took a photo of that. So
Nice.
So
I
you
love
can.
the frame you made around it too, by the way.
Yeah, I have another picture that I showed earlier that I'll put up again. You can get kind of creative with these pinhole projections. If you're watching the eclipse and you're a little bit bored, you can do stuff like this.
Oh,
So
that's amazing.
I drew a little picture with a pen, and then I projected the eclipse onto that and took a photo of that.
Fantastic.
So
Yeah,
I have this picture on my office door to remind me how amazing astronomy is, and how you can do some pretty cool stuff just with alignment of the solar system.
If your online avatar was not a PhD comic character, I think you should totally make that your avatar. That is
fantastic. Yeah, I had some fun with that.
So it's going to be fading out here pretty soon, and Thad's back. What's up,
Hello.
Dr. Thad? Have you scienced your students hard today?
I think they've been scienced pretty well.
Yeah? Have they learned anything? What's the biggest question?
What's the difference between narrowband and broadband?
And we have gone over that multiple times. What is the difference between narrowband and broadband?
So, you get a white image with broadband because it lets all colors through.
Right.
And so it combines to make white. And with the narrowband, it's only letting the transition in the hydrogen atom, the particular wavelength that goes with that through. So if any of my students are watching, it's 656.3 nanometers.
Yes.
But I think they need to get that. I think they need to get that before they turn their thing in. So
Test question.
Yeah.
Test question. Your answer is on YouTube. Test question. And it's not officially cheating since your professor told you so.
You can really see that filament again in that in the H alpha sun picture now. It's absolutely fantastic. And this is something that doesn't show up in the white light pictures of the sun. If you've seen white light images of the eclipsed sun, you can still see that sunspot, but you can't see the filament. So this is something that really only comes out when you've got that narrow filter, only letting a certain wavelength of light come through.
I love it, and I'm really happy we were able to get our feedback up online, especially since we're starting to see the end of it. It's moving away now, but it gives us a chance, just being able to look through this Coronado telescope, to be able to see just how dynamic our star is. That it's not just this ball, this circle in the sky. That there's so much activity going on all the time. It's pretty violent. Lots of enormous explosions happening all the time, and even their enormous explosions have even more enormous explosions. So it's not like a scale of, how many atom bombs are going off. It is far beyond that.
Go ahead. I was just gonna say, that active region is about the size of Jupiter, right? And the Earth is only about less than the size of Jupiter's great red spot. So the Earth on the scale, it's just tiny. It's like just a few pixels, and just to think the entire planet would be utterly engulfed many times over by that active region, that sunspot region on the sun. And you know that filament is like many, many, many times longer than the Earth is big. It's hard to even imagine those scales.
It is, and we're also, our star is really not that big. It's not that large of a star. It's a pretty
That's
ordinary
middling.
star.
Yeah.
And and yeah, it's something to really blow your mind when you think that like this is average. This is, you know, we're finding a lot more stars that are similar to this, and you know, throughout our Milky Way, but there are some enormous, super, super, super hot stars that honestly put the scale, the way that our planet is to our star, would be like the Earth is to this super, you know, or like the sun would be like our planet to that super, super huge star. The scales are enormous.
Yeah. Yeah, it's pretty. It's there's a lot of really big things in the universe, and our sun will get bigger someday as well. In something like 4 billion years, our sun will enter a red giant phase. So it'll puff up and it'll engulf the orbit of Mercury and Venus, I believe, and I think, and it'll boil off all our oceans and just get super hot. And I'm not sure if it'll quite engulf the Earth, but it'll get pretty close, and that'll be pretty clearly the end of the world. I don't know if the planet will survive, even just like even if it doesn't get completely engulfed by the sun. I don't know if it can keep orbiting at that distance. I think it'll probably just be eaten up somehow, one way or another. But in any case, it'll certainly sort of fry everything on the planet. But you know, we've got 4 billion years or so to figure out some kind of contingency plan. Go somewhere else, maybe fund the space program.
We already have Andromeda heading right for us during that time, so it'll be a closer trip to another galaxy.
That's true. Yeah. Andromeda is so it's somewhere in the range of 4 billion years. Both will have a couple different things happening. One is that the sun will fan to a red giant. The other is that the Andromeda galaxy will collide with the Milky Way. The sun expanding is actually much more dangerous for us as a planet than the Andromeda coming. Andromeda colliding with the Milky Way probably won't even mess up our orbit, because there's so much distance between stars in galaxies that when galaxies collide, usually the stars don't. They just kind of sail past
like
each other.
Two swarms of bees colliding. They just fly right by each other.
Yeah.
There will be some gravitational perturbances as the two galaxies merge into something else. And some of the dust, we'll see some starbursts, going on.
Yeah, that'll be cool. But yeah, hopefully we will not be on, the sort of fried, charboiled Earth at that time.
Yeah, well, I do plan on living forever, so I'm hoping by that time we figured out somewhere else to be. And I'm hoping for another solar system. I figure if we're gonna leave, let's go somewhere pretty cool. Let's go far away.
Yeah.
And see things from a different perspective for a while.
There's so many solar systems out there too. I mean, we've found over 1,000 planets around other stars at this point.
Yeah.
It's
I think
kind of amazing.
Over 3,000 now with the Kepler data.
It depends on if you count the just the candidate planets or actual confirmed planets.
Confirmed, right?
Yeah. So I actually looked this up the other day because I was giving a lecture about life in the universe for the astronomy class I'm teaching.
Is that what you sent me on Instagram?
Yes.
Okay.
Yes, that is.
Okay. Complete side conversation here. But I was wondering what the context was.
So I was giving this lecture about life in the solar system, or life in the universe, and life around other planets. And so as of Wednesday afternoon, the number of confirmed exoplanets, planets around other stars, is 1,516. It's probably higher now, but as of 2 days ago, that was the number. And in terms of the unconfirmed planet candidates, there were 3,359.
Nice.
So there's a lot of planets out there. We think that there's probably at least one planet around every star on average, and most stars seem to have more than one.
Exactly. I think it ends up. I think the average was around 1.6 planets for every star.
Yeah. Yeah, and we know that multiple planet systems are very common.
Right.
Because we've seen several of them.
We didn't know that. We didn't,
No.
At first we didn't know if there were any other planets around any other stars. And they're like, oh yeah, no, there are. And now we're seeing that there are more multi-planet systems.
Yeah.
And that's just awesome. We're finding out that in some cases that we're not as special, which also means that the processes that allow for us to exist might not be as rare as we thought it would be.
Yeah.
Especially if we're finding more and more planets in the Goldilocks zone.
So over on Twitter, Grant McKinney just suggested that the length of that filament is probably about as long as the distance between the Earth and the Moon, and that looks about right to me, based on the scales. Order of magnitude, something like that. I think that's probably about right. So that filament is really long.
Yeah. And that's one thing that it's funny. I've shown and I've done the math for, but yeah, all the planets in our solar system can fit between the distance between the Earth and the Moon. Someone asked me that like a few weeks ago, and I did the math on it, and it's true. They could all fit in there. And I'm like, that's really amazing to think about.
The Moon's a lot farther away from us than we usually realize. It's if you do it to scale, if you have like a basketball as the sun or a basketball as the Earth and a tennis ball as the Moon, you have to put them like 7 meters apart to get the distance right. It's a pretty big distance. Not really obvious, but it's big.
It is, and talking about tiny terrestrial planetoid objects. I mean, these are just tiny things in the universe, and putting things to scale really gives you a chance to think about the other things that we can learn about, like theoretical astrophysics and cosmology, like Katie does. So as we're seeing here that the eclipse is coming more to an end, I do want to thank you for waking up early and doing this, and especially since this is not your wheelhouse, but
no.
It's still
cool.
It is cool, and so I guess I want to let our viewers know on Katie, yay, that's awesome. And yet she's a theoretical astrophysicist working on the very, very early universe.
Yeah.
And that's, again, just we have shows similar to this, shorter in length, every fortnight, so every 2 weeks, and where we do dig into things. So our recent series is on the cosmic microwave background. We've done some on supernovae, on dark matter. So make sure to follow Katie on Twitter at AstroKatie. Stay tuned for more shows from us at Know the Cosmos. And we love to dig into awesome science and try to break it down for ways to make it a little bit more accessible, because dark matter and stuff like that is pretty difficult to comprehend. And so we try to take our time and I like to make jokes. You're more the straight man in the group. I crack wise, but I think we've had some pretty good success for it so far, and we're always looking for recommendations from everybody else. If there's anything else that you guys want to see or know about, let us know, and we will definitely bring that on.
I just want to show something that I found through through Twitter right now. Someone just tweeted this picture of the comparison between the Earth-Moon distance and the size of the active region on
Oh,
the
I love
sun.
it.
And it
That's
really is
awesome.
about the scale that we thought. So in that picture, you can't see that filament, but of course, if you look at our image of the sun, you can see that the filament really is about the length of that the Earth-Moon distance. So
That is awesome.
yeah, yeah.
So
it's
yeah,
very-
imagine there's that distance between the Earth and can you bring it back up a little bit because we're watching just the very end. I'm talking to Thad. Sorry.
Okay.
So we're seeing the distance between the Earth and the Moon. Imagine if there's this enormous band of plasma that is on this magnetic loop between us, frying everything like an uber laser of doom. Even though it's not a laser. It's not a laser. That's completely
Right.
different. But that's what we're looking at with that darkened thread, and that's just amazing.
Yeah.
It's leaving us. No.
The eclipse is ending. It's
It is
almost
ending.
over.
I'm glad that we're able to get the
there's-
connection back. What's that?
There'll be another one in April of 2015, I believe.
April
That
20th.
I think you'll be able to see from where you are. I won't be able to see it, but I think that you guys will be able to see it. Or no, sorry, that's a lunar eclipse. There's a lunar eclipse in April 2015.
I know in
and you guys should watch that.
2017 there is a total eclipse that I'm either going to like the St. Louis area or I'm going up to Seattle. I'm thinking for clear skies more of St. Louis, but I really want to go to Seattle because I love Seattle. But there's
Good
clouds in Seattle quite a bit.
Oregon.
Yeah.
Oregon
Eastern
I
Oregon
need
Desert.
to-
Apparently. Go ahead.
I'm going to need to get going pretty soon, but it looks like the eclipse is almost done. Can you remind us when we're doing our next hangout to talk about the cosmic microwave background?
That's a great question, and I don't have my calendar in front of me, but it is soon. It's,
Something like next week, probably.
I think it's next weekend because I am being selfish and still finishing up my birthday.
Happy birthday, by the way.
way. Thank you. But so not this weekend, but the weekend after. So it's midnight Saturday morning here Pacific time. It's Saturday afternoon. What, 5 p.m. for you?
Yes.
5 p.m. And
so it's the midnight between Friday and Saturday for you, LA time. Yes.
Right.
Okay.
And that's when we'll do that, and we'll be doing part 2 of our cosmic microwave background. And let's all wave goodbye to the eclipse because it's just eking out. It's tiny, teeny. I think it's going. It's gone. I'm pretty sure.
It's not quite gone. There's a little. I can see a little tiny bit.
Little tiny bit.
Still there.
Moon, go orbit backwards.
That would be bad. That
would be really awful. We do not want the moon to orbit backwards.
No.
I changed my mind, Moon. Keep on with your bad self. I think that's it.
Yeah, it's kind of it's pretty gone now.
It's gone.
All right.
Well,
this was a lot of fun.
Yes,
Thanks.
thank you for joining us from the future in Australia.
It's a
and waking
beautiful,
up
it's a
early.
beautiful Friday morning here. So you have that to look forward to.
I hope so. We'll see what Friday turned out to be here in LA. Again, for those of you watching, thank you for watching us. Follow AstroKatie on Twitter. Also, there's astrokatie.com, Katie Mac on Google+. And you now have your own page on Facebook as well.
Yes,
as your...
it's facebook.com/AstroKatie. If you would like to see what I'm up to on Facebook, go to facebook.com/AstroKatie. Don't send me a friend request as a person because I probably won't accept it because I get friend requests from people who know me through Twitter and stuff, or who have seen me on Twitter but don't actually know me, and I tend not to take those because there are lots of people out there, and I would have a million, Anyway, but find me on Facebook through the page, and you can like the page, and then you can see all the stuff that's going on there.
Absolutely. And so there's the sun, no longer with the moon.
No longer with the moon.
And here is the Thad. There we go. So Thad Zabo, Dr. Thad Zabo, or as I call him, Astro Jesus. Thank you for having us out.
Yeah, no problem.
It was
Glad we
great.
could accommodate you. Sorry we couldn't provide more shade, but
Let's
the sun at the low elevation it is at this time of year. I mean, I see it. My solar panels don't produce as much, and we get a little fried when we try to watch events like this. But
it
I think
happens.
it was worthwhile.
I'm a ginger. I'm used to bursting
Yeah.
into flames. So I am Scientific Scott on Twitter. You are
AstroThad.
AstroThad on Twitter. This has been part of Know the Cosmos. We're at knowthecosmos.com. I'll be putting an update on that as well. And we will see you all next time. Thanks a lot for watching.
Bye.
Bye.